Greetings, everyone. My name is Lovro, and today I'd like to talk about seeing eye to eye, aligning human and machine vision for deepfake detection. Now, all of us have probably heard of deepfakes. It's a video, image, or audio that has been either completely generated or altered in some way to show us something that doesn't really exist. This is not really Tom Cruise, but it has his face on it. Now, when we look at the progression of deepfakes, we can see that it's quite astonishing. For example, a video of Will Smith eating spaghetti in 2023 is obviously fake. We can see it, we can understand it semantically that it's fake. But the video made in 2025, so a year ago from now, it's already harder to say if this is real or if this is fake. Now, you might ask yourself, okay, deepfakes are getting better and better. How can we prevent them? Well, the short and not so sweet answer is that we can't. The Pandora's box has already been opened, and the internet is already being flooded with millions and millions of different deepfake content. And yes, it might seem fun, it might seem entertaining, but whenever you introduce a new type of technology, there will be individuals or companies who will basically try to misuse it, and watch out for AI scams. Now, when I researched this topic, I managed to find different research done in different years using different technologies, but I managed to find a few patterns. So for example, if I look at the human pre- and post-training accuracy in detecting deepfakes, we can see that humans are better when they are trained. So when they are told, please look for certain things, when something weird is happening around the face, that might indicate that this is fake. And the same thing happens with the AI detectors. So when we have a machine which is detecting if the content is made by another machine. So it also has to be trained and retrained on each new deepfake style. Now, okay, so what's the issue? We just train the new AI detector when the new deepfake model releases. But the problem here is the deepfake arms race. So let me explain. So let's say Google, Meta, OpenAI, they release a new deepfake model. When it's released, AI detectors will fail. They will not be able to detect them. And then when the researchers collect the data, AI detectors will fail. When the learning period starts, AI detectors will fail. And then finally, when the training is completed, AI detectors will succeed. But this period can last from months to even years, which means that during that period, we are vulnerable because we cannot be sure if this is fake or if this is real. But of course, there are some ways where humans can speed up this process of training AI detectors, and those are called human and AI collaboration systems. But of course, there are problems with this as well. So the current problem, I will try to illustrate it in the simplest way possible. So a human was shown a video, and the human said, I think this video is real. And then the AI watched the same video and said, I'm 90% sure this video is fake. And then the human, when he saw that, switched his answer and said that the video was fake. But the video was real. And the real problem here is that current collaboration systems only share a percentage and not the reasoning behind it. If an AI detector tells you it's 75% sure it's fake, but it gives you no proof, how can you trust it? So what we need to understand is, where are humans and AI actually looking at when making these decisions? Now, of course, there was a research which told us where humans look. It was conducted on 40 people using eye tracking technologies. An eye tracker is basically a device which tracks your eye movements around a video. And the red area is where you are focusing the most, and green is where you didn't focus a lot. And heat maps are basically where humans look. And humans are usually focused on areas around the face. So it's basically quite simple because it's our primal brain, when we have to detect faces, that we have it in our DNA. Now, of course, there was another research which told us what AI sees. Of course, AI cannot see. AI detectors have no eyes. But what they can do, they can calculate data. So each video is made out of frames, and each frame is made out of pixels. And each pixel is made out of 3 different colors. So what we can do, for each of those colors, we can take a number. So what we can do, we can take for each color, for each pixel, for each frame, we can take millions and millions of numbers, we can give it to the AI detector, and he will basically be able to see what is happening on the video. And then they will generate what is called a GradCam visualization, which is basically AI heat map, which tells us where AI detector looks, or more accurately, where AI detectors will focus their resources on. And they're usually focusing also on the areas around the face, which is simple. And now you might ask yourself, okay, we know where humans tend to look in deepfakes, and we know where AI detectors tend to focus in deepfakes, but always on different data sets and experiments. No one has asked on the same deepfake video, where are human eyes and AI looking at the same place when they decide is something real or fake? So I would target this gap by directly comparing those two heat maps. So I would compare the human heat map with the AI GradCam. So I would compare where they're both looking, and I would align those two heat maps, and then basically see how accurately are they aligned. And the hypothesis is when the alignment percentage is high, that means that the overall accuracy will be higher because they were both looking at the mistake on the fake video. But when the alignment is low, meaning humans were looking at one place and AI was focusing on another, the overall accuracy will be lower because somebody was looking, or something was looking at the wrong place. So I would conduct this research by finding 50 people. I would show them 50 real and 50 fake videos played at random so they don't know what is real and what is fake. I would generate those human heat maps. I would basically do the same with the AI detectors, which would also generate those AI heat maps. I would overlap them in an overlap analysis, calculate the alignment percentage. I would also take the human and AI detection accuracy, calculate the overall accuracy, and then basically see if there is any correlation between those two. And the expected findings are when the alignment is high, meaning both humans and AI detector are looking at the same place, that the overall accuracy will be higher because they were both looking at the mistake, and both will usually be correct, or their percentage in detecting will be higher. And when the alignment is low, meaning humans are looking at one place and AI detector is focusing on another, overall accuracy will be lower and the results will be complementary. And for future work, first of all, I need to select an AI detector, so a tool which will help me generate those AI heat maps so I can see what the machine is thinking. I need to build a video data set, so I need to find 50 real and 50 fake videos, which I'm going to show to people and to the AI detector. And I need to design a human interface. So basically, I need to make this survey using the eye tracking technologies, and I need to save all of that data. A lot of work. Now, in conclusion, why this matters? Well, deepfakes are rising fast. They are here, they're not going anywhere, and we need to learn how to live with them and how to spot them efficiently. Because unfortunately, humans and AI alone are not enough, and the only way forward is together, because together we can catch more deepfakes. Thank you for listening.
Thank you so much.
Thank you.